Hello, I am Gun Lee, a student at Yonsei University. I am going to present our work, Camera-Driven Representation Learning for Unsupervised Domain Adaptive Person Re-Identification. First of all, I will explain the task we have performed. It is to transfer knowledge learned from a source domain to re-identify persons in a target one, where ID labels for the source domain are provided only. This enables performing re-ID on the target domain without additional annotations. A baseline model for domain adaptive person re-identification exploits two phases of training. First, they train a re-ID model on the source domain with ID labels. They then extract features from target images, using a re-ID model. And they apply a clustering algorithm on the features. They then assign the same pseudo-ID label to the images which belong to the same cluster. They alternate between clustering and fine-tuning with these pseudo-labels. The baseline model mainly has two limitations. First, they focus on transferring knowledge from source to target in a domain level. Secondly, pseudo-labels for the target domain are highly biased towards camera labels. To overcome the first limitation, we introduce a novel curriculum learning framework called Camera-Driven Curriculum Learning. We perform a progressive adaptation exploiting camera labels of person images. We first decompose a target domain dataset into multiple subsets with respect to the camera labels. We consider maximum mean discrepancies between each subset and the source domain dataset. A closer subset with respect to the source dataset is exploited earlier within the curriculum. Our curriculum learning with a camera-driven scheduler provides the following advantages. It allows a smooth adaptation from source to target domains in a progressive manner. We start to learn from person images obtained using a single camera, then progressively expand to other images captured from multiple cameras. To overcome the second limitation, we leverage a camera diversity loss. For clusters of images obtained from the same camera, the weighting factor becomes 0 and discards the clusters for training. For clusters of images captured by different cameras, we assign a large weight and allow them to involve more for feature learning. We incorporate cluster-wise weights to enhance cross-entropy and triplet terms used for training re-ID models. We compare our method with the state-of-the-art on the real-to-real and synthetic-to-real scenarios in tables. We present in a table an ablation analysis of our methods to show the effectiveness of each component. We show in a figure visual comparisons of retrieval results with the state-of-the-art and variants of our model. We can observe that ours provides better results than UNRN and IDM. We propose a CACL framework, gradually transferring the knowledge learned from a source domain to a target one. We have also introduced a novel CD loss, mitigating a camera bias in pseudo-labels and handling inter-camera variations. Thank you.